In this lesson, we're looking at some of the inverse properties of logarithms. We discussed a couple of the properties of logarithms and kind of how these things work and the relationship they have with exponential functions. But today we're going to start talking about the inverse properties of logarithms. And essentially what's happening here, if we look at these, the first one says log base b of b equals 1. The second one says log base b of b to the r equals r. And really each of these is saying the same thing. This first one over here, this guy is just a special case of the second example. And so what's happening here, the reason these are called inverse properties is because if I think about this for a moment, if I were to scribble this out, this is an exponential function, b raised to the r power, okay? But when I look at the whole thing, if I kind of ignore the r for a moment, this is just a logarithm. And so what's happening here is I have these two opposite pieces, the logarithm and the exponential function. Remember, logarithms and exponential functions are inverses, therefore they cancel one another out. So when we look at this, what's happening here is log base b and b raised to a power. These two pieces are canceling each other out, so the logarithm and the exponential part are canceling each other out, and it leaves me with just the exponent, which is the r. All right, and the reason this first one is the exact same thing is because when you think about it, think about what the exponent here is. This is b to the first power. When I don't see an exponent written there, it's the first power. And so it's the same thing. Log base b and b raised to a power cancel out, and I'm left with the exponent, I'm left with the 1. So really, as long as you remember this second guy, you'll be in good shape because technically this first property is really a special case of the second one, okay? So again, log base b and b raised to a power cancel each other out. For example, here this is going to give me a 1, and the reason it's going to give me a 1 is because the exponent here is 1, and the log base 2 and the 2 cancel each other out. Okay? For the next one, this is also going to give me a 1 because there's a 1 here, and the log base 3 and the 3 cancel each other out. The next one, again, there's a 1 here, so this is going to equal 1 because the log base 5 and the 5 cancel each other out. If I look at the next one, again, we're using that same property. The log base 2 and the 2 cancel each other out. So log base 2 and 2 raised to a power cancel each other out. So I'm left with a 5 this time. Okay. In the next one, again, the log base 3 and the 3 raised to a power cancel each other out. So it leaves me with just the 2. And in this one, the log base 5 and the 5 raised to a power cancel each other out. So it leaves me with just the 7. All right. So now here's how we can apply this rule to help us simplify some things. If I look at something like this guy, here we've got log base 2 of 8. So log base 2 and 8 don't really cancel each other out because it's not the same base. And that's what we're looking at here. Log base 2, like in the example above, log base 2 and the 2 cancel each other out because it's the same base. And so the inverse and because these are inverses, the logarithm and the exponential function, they cancel each other out. Here I don't have that. I've got log base 2 and I've got an 8, so I'm going to rewrite it this way, and maybe you can see it already, but this is log base 2 of, well, 8 is the same thing as 2 to the third power. Now I have the same base. Now log base 2 and the 2 cancel each other out, and it leaves me with just a 3. And so when you think about it, it's really the same thing that we did when we were solving exponential functions by getting common bases. In that case, we were trying to get the same base on each side of the equation so we could set the exponents equal to one another. Now we're trying to get the same base for the logarithm and the exponential function so that they can cancel each other out. All right. Same thing here. I need to have the same base, so this is log base 3 of, well, 81 is the same thing as 3 to the 4th power. Now I have the same base, so the log base 3 and the 3 raised to a power cancel each other out. Leaves me with a 4. Okay? The next one, again, I need to have the same base in order for these to cancel, so I'm going to do log base 5 of. 25 is the same thing as 5 to the 2nd power. Now I have the same base, so the log base 5 and the 5 raised to a power cancel each other out. Leaves me with a 2. Okay? But again, these are the inverse properties, and we'll have one more inverse property of logarithms, but these are inverse properties of logarithms because it uses the fact that logarithms and exponential functions are inverses to cancel one another out. So logarithm, if the logarithm and the exponential function have the same base, they cancel out, and I'm just left with the exponent. Okay?